We're live, I think. As always, if I require some kind of external confirmation of my existence to know that this is actually happening. And if it is, let me know. Hey everyone, Fraser here. So this is just a holiday special of the of open space. And if you're wondering which holiday, it's of course Canadian Thanksgiving. I hope you've all had a wonderful Thanksgiving with your friends and family. Enjoyed turkey or the vegan equivalents, which is what we do around here. We decided we were going to call it Cakesgiving, and so we just made a big chocolate cake and just fed. So it was good. So if you're wondering what this is, of course, this is just an open, no format, no holds barred. Hit me with your questions and I will talk about them. Stuff that's happening in sort of now, recent news events, things that you want me to opine on, and also a way for us to chat and for me to think of new topics and new ideas. If you're wondering what's coming up, the patrons have already seen it, but we just released a new episode on a 2-stage aerodynamic space plane. So it's sort of like, it's the coolest idea I've seen in a long time. So it takes off from a runway, flies to a high altitude with jet engines, turns into a rocket, flies to about just shy of 100 kilometers, detaches, the booster flies back down and lands on the runway, and then the top part flies up to orbit and then does some kind of payload thing, whatever, and then it re-enters the Earth's atmosphere and comes back down. And it's a really cool idea. So that's tomorrow. It's called the Astro Clipper. And then I haven't really decided, but I think at the end of this week, I'm going to do an episode about, people always ask me, like, if we discover that there are aliens out there, will people freak out? And my answer is always no. That I think that we won't freak out, just because you would be amazed at how well or how easily human beings can be bored out of their minds by anything and just go on with their regular lives. And in fact, we have discovered aliens many times in the past. Think about Percival Lowell thinking that he was seeing canals on Mars. There's the WOW signal. There's the discovery of the Viking missions. People thought that maybe there was life there in the experiments that were being done with the Viking. There's of course the Mars meteorite that seemed to have life forms inside. And there's been a bunch of other examples of this, even UFOs, right? A lot of people feel like that's evidence that there are aliens that are visiting us and mutilating cattle. And the response is always fairly measured, fairly kind of meh. So I think I'm going to do an episode on that. And in fact, there was an interesting article that came up from Seth Shostak at the SETI Institute, fairly similar to that, but I'm going to sort of go into a lot more detail. So anyway, so that's I think the plan right now. And then we've got a couple of other interesting, I want to do an episode on asteroid mining. We've done one before, but there's a lot of really interesting stuff that's just come out. There's this biofilm mining that NASA is considering. There's a really interesting paper, we just covered this, where they took some lunar regolith and they just extracted out all of the oxygen, and what they were left with was a pile of metal. And it just really shows you what the raw materials are that are out there. And there's a few other interesting ideas. There's a company that received some funding, and they're just going to surround an asteroid in a bubble and then just digest the whole thing. So there's sort of like a bunch of interesting ideas about asteroid mining. They're all fairly new, and so I think that's going to be the next thing that we'll be tackling just after that. So Nestor says, just about to start my math homework. Great timing. What do you mean? I'm distracting you from your math homework. This isn't right. Go do your math homework. But feel free, if you have some questions from your math homework, just throw them in, and we'll try and take them, take it to the community, and maybe we can help you out. All right, well, so let's get on with some thoughts. So Curious Borg asks, isn't that similar to Virgin Galactic's rocket-assisted space plane? So I mentioned Virgin Orbit, which is the company that's doing this in the video. And no, it's not. Virgin, it's an airplane like a 747 with a rocket that it holds underneath, like a Minotaur or a Pegasus, and then the rocket drops and then flies off, and it drops stages. This thing is no stage, or it's stages, but every stage of it is reusable. Anyway, that's tomorrow. Like, patrons, you've already seen it. Everyone else, you'll see it tomorrow. De Soleil says, how do planets capture moons? Asteroids are going to fly in a hyperbolic trajectory past a planet. How does the trajectory get changed to become elliptical? So this is a great question. So you think about how there could be captured asteroids in orbit around the various planets. And sort of the most dramatic example of that is something like, say, Triton, which is one of the moons of Neptune. And it's not really a captured, asteroid. It's gigantic, right? It's huge. It's a Kuiper Belt object. And so the question is how, and one of the things why astronomers think that it was a captured object is because it goes backwards from the rest of the moons of Neptune. And so the question is, how do you do that? And so the answer is with some kind of three-body interaction. So you're exactly right. If you've got an asteroid falling into the gravity well of a planet, it's going to fall back out of, it's going to head back out of the gravity well, and it's going to fly off into deep space, or continue to orbit the sun. So you've got to have some other interaction, and it takes three to tango, right? So you've got to have two objects that are lending their gravity, and then this third object, this asteroid. And that's how you can get a capture. And so you would imagine, say, an asteroid coming into the Earth and the Moon, it came close enough to the Moon that it got tweaked by the Moon, and then it got tweaked again by the Earth's gravity, then it could get captured. But if it's just, it's coming in, coming back out, then it can't get captured. 10-ton CAG. Hi, Fraser. Why are quasars so far from us? Do quasars belong to the earlier times of the universe necessarily? Quasars are, of course, the actively feeding cores, the supermassive black holes at the hearts of galaxies. Almost every single galaxy has one of these supermassive black holes. And when large amounts of material falls onto these black holes, it piles up, turns into sort of like this big accretion disk that wraps around the black hole, like a solar system almost. And it gets so hot that the quasar can release more energy, more radiation than the rest of the entire galaxy combined. And so that's why we see them, is that these quasars are incredibly strong. They're incredibly powerful. They're giving off more light than an entire galaxy, and it's at a point source. So it looks like a star, but it's actually, the entire energy of a galaxy. And so that's why we see them. There aren't a lot of them out there compared to other things, but they are incredibly bright. And so you can see them all the way across the universe with things like Hubble Space Telescope. And you can even observe quasars that are hundreds of millions and even billions of light years in a backyard telescope if you know what you're looking at. It looks like a star, but it's actually the most distant object you could be possibly seeing. And the reason we're able to see them is just because they are so bright. And so the thinking is that we are actually beyond the age of kind of the main activity. The party is over. And really the party was happening just a couple of billion years after the formation of the universe. That's when all of these quasars were popping off. That's when all of the star formation was happening. And now as the universe is getting older and it's settling down, we're not seeing as many of these active galaxies as we did in the past. Samuel Baker says, in one of your past episodes, you said in theory that you could make a black hole with photons. If photons are massless, then how? Right, so with black holes, you can only know a couple of things about black holes. You can know their mass and you can know their spin, but you can't know what they're made out of. And so astronomers will say that black holes are just kind of made of black hole. And the reality is that you can throw mass into a black hole, you can throw energy into a black hole, you can throw antimatter into a black hole, and it all just turns into black hole. And so if say photons are massless, how can they add to the mass of a black hole? And they absolutely can. And it's because they have an equivalency. So you think about E equals mc squared, right? Energy equals mass times the speed of light squared. And so that equation goes both ways. So if you have mass, you could release an enormous amount of energy, and that energy, if it fell into a black hole, would add to the mass of the black hole the same amount as the original mass. If you shot a laser at a black hole, it would increase by the amount of mass of the photons via E equals mc squared. So they're just interchangeable. And in a black hole, there's no difference. And that's why if you add an entire black hole's worth of antimatter to let's say you just throw stars of antimatter into a black hole one at a time, each one will just, they'll add to the mass of the black hole because they're not, they don't cancel out a black hole, whether it's matter, antimatter, or the energy combined from matter and antimatter, it just adds to the black hole. Can there be an interview with an expert on electrogravitic lifters? What's an electrogravitic lifter? Is that a thing? That sounds like, is that like some kind of UFO technology? I've never heard of that before. So if you can give me like more information, that would be great. CLC, would you rather live 1 year on Mars or the moon, and why? That's interesting. If you were, man, I don't know. Okay, so let's see. I think I would rather live on the moon for 1 year and then I came back. So partly it's because it's really close. It's like a 3-day journey to go to the moon. So that's cool. The gravity is lower. And so that would be fun. You could like jump really high and you could like put on a pair of wings in a big enclosed habitat and fly around. That'd be cool. The moon is such a kind of alien landscape. And there's like a lot of really interesting things that you could sort of look at. And then, of course, you could see the Earth, and it would just be this thing that was always in the sky. And then you could, of course, tour around. You could see the Apollo landing sites. Mars it's kind of like a desert. Like we've got places that look like Mars, right? They're deserts and there's sand, so it's different. But in both cases, you need to spend a lot of your time underground. But if I had to pick, I would probably go with the moon. But that's just me. Tim Smith asks, whose rocket system will launch James Webb? So that's going to be on Ariane 5. And this is one of the last payloads are going to be launched on an Ariane 5. They come out of the launch facility that's in South America. And so right now, James Webb, they've finished sort of the construction of it. They've put all the major pieces together. And the next step really is for them to take it down to South America. They're going to put it on a barge, take it through the Panama Canal, take it down to the launch site and in French Guiana, and then take off in 2021. Yeah, March 2021. And I haven't heard any sort of bigger delays. So at this point, I think right now this is still the launch date. And of course it's going to launch, and of course it's going to be safe. Now the Ariane 5 is a very reliable launch rocket, one of the most reliable. So here's hoping. Powell Zersky says, what's the limit on a planet mass to make chemical rockets useless to get to space? So this is that's a bit of a trick question, the way you have described it. So the mass of the planet definitely matters. The density of the planet matters as well. So you could imagine if you had a planet that was, say, the same mass as the Earth, but it was the size of the geosynchronous orbit, then you could just jump off of the Earth and you would be in orbit, right? You would fly off into space. You would escape from the Earth just by jumping. And the density of the Earth would be very small. So really the mass and the density and the radius, they're all intertwined with each other. But I think the question you're really asking is like, if you had double the gravity, the surface gravity, if you experienced twice the surface gravity on a planet than you do here, what, would you be able to have a spacefaring civilization? And actually, Scott Manley did a video of this. I hope somebody can find it and put it in the chat. But if you check his channel, you'll be able to find it. And he was able to make essentially a Saturn V rocket was able to launch a very small communication satellite, like a Sputnik, into orbit. And that is like the biggest limit. I mean, you could imagine like a really technologically advanced civilization who was trapped on a twice Earth gravity surface. They could, with a lot of work, they could launch a couple of rockets, and then hopefully those rockets could bootstrap the rest of their interstellar civilization. But they would have a really hard time. They would be the billions of dollars to launch tiny communication satellites. And then beyond that, you're pretty much limited. I saw a calculation one time. I mean, it still does work. You could even go more. You could do 3Gs, 4Gs. You could imagine, I think if you were able to if you had like a 10 Gs, it would take half the mass of the universe as your rocket fuel to be able to launch a rocket into orbit. So it gets expensive very quickly. Really, we're really lucky with the surface gravity that we have here on Earth that we can't even do this at all. But people always think about like these super Earths, like a planet with double the mass of the Earth. But the reality is they're not necessarily going to have twice the surface gravity because they're going to be bigger. And if they have the same density as the Earth, they actually have, like, say, 1.5 times the surface gravity. And if they're less dense than the Earth, they could be, say, 40% bigger and have the same surface gravity. So it all just comes down to density, radius, mass. They're all intertwined. Harambe's Ghost. Do you belong to an astronomy club or do you prefer to observe an image alone? That sounds so sad. I live in a pretty small town. Apparently there is now an astronomy club here in my city, the city of Courtenay, and I think they meet at a bar once a month. So I may go sometime for fun. But generally, I'm pretty spoiled at this point, thanks to good friends at Oceanside Photo and Telescope. They've got these great, these amazing telescopes that I can access remotely from right where I am right now. And it's like a super fast telescope that takes really amazing images. And so I'm so spoiled. Like, it's hard to explain the difference of how much easier it is to sit, at your computer and access a telescope half a world away that is far more powerful than anything you could ever use. So I'm really spoiled, but I do really enjoy, I love taking like a Dobsonian telescope out and just shifting it around and looking at the moon and Saturn and Jupiter and things like that. I should buy another Dobsonian, another one. Anyway, let's move on. Samuel Baker. All right, so in my head, you put antimatter into a black hole, you would cancel out the equivalent of black hole matter. I guess I'm not grasping how matter and antimatter interact with black holes. No problem. I'll take another crack. I mean, I did a whole video with this, but I'll try and give you one where you go like, okay, I got it. So matter and energy are interchangeable via Einstein's E equals mc squared, right? E equals mc squared. Energy equals a certain amount of matter, and matter equals a certain amount of energy. They are interchangeable. And when, for example, let's say you feed a star to a black hole. Now, the star takes everything that's going in there. It takes the mass of the star, and it also takes all of the energy of the star. So let's say the mass is, 1, and then the energy equivalent, or the mass equivalent of all that energy is like another 0.001 on top of that, right? And that all gets added to the black hole. And so the mass of the black hole goes up by that amount. If you take antimatter and matter and you merge them together, you get pure energy, and the amount of pure energy is equal to that E equals mc squared. It's just energy released out into the universe. But in a black hole, that energy can't be released out into the universe. It remains there. And so you get a black hole. So if you have a 1 star's worth of matter, you have 1 star's worth of antimatter, you put them together, you get 2 stars worth of energy in a black hole, which can't escape. And so it just, you end up with a black hole with twice the mass of a star. But there's no way to know what it actually is, whether it's matter, antimatter, energy, anything. And that's this idea of a Kugelblitz, right? That you can just like pack energy so tightly together that it turns into a black hole. And in theory, that's possible. Christian Woodland, do you think that Expanse type space engines will happen in some form someday? I don't know. Nobody knows really what the future holds in this kind of thing. Obviously with chemical rockets, with nuclear rockets, that's not going to do the trick. Maybe fusion-based rockets might work. Maybe with metallic hydrogen, you could get a level of energy density that you could have those kinds of thrusts. But we don't know what the future holds. And so it's really important to understand that the job of these engines in science fiction is to make the story go faster, right? Like the warp drive in Star Trek or the hyperdrive in Star Wars, they take you to another world. And it's not because they're possible, but it's because it makes the story less boring. And of course it would be wonderful if these things someday would work and that we could flit about the universe. If they could, once again, it starts to make you wonder about the Fermi paradox, right? If it is going to eventually be possible for civilizations to move faster than the speed of light, where are they now? Why aren't they here? So does that mean that it will never be possible that everybody is trapped in their solar systems and nobody will ever be able to invent faster technology? So, I hope someday. I think that what we're going to see in the sort of far future is we're going to just see a civilization here in the solar system to start with that just has a lot of infrastructure, right? Like when you hop in your car and you drive across your country, you're stopping at diners, you're refilling your vehicle, you're getting maintenance, you're getting new tires, whatever you need to do to be able to go across all of, the entire country. And that's because of infrastructure and the roads, right? And electricity and all of these things, they make it possible. And a car takes as long as a car takes, and an airplane can go quicker, but it also costs more money and it creates more pollution and so on and so forth, right? So I think that we're going to have a future, eventually we'll have more and more infrastructure. Imagine these ideas of like lasers that can accelerate solar sails. And so you can imagine there's a whole bunch of these lasers set up across the solar system and they fire at various times, or there are places where people can refuel and get more water ice to be able to refuel their spacecraft and so on and so forth. And I think that's more what the future looks like, is just as we get more and more established into the solar system, we get our infrastructure built up, it allows us to go safer, reach out farther into the solar system. And that's just sort of how I see it. But I could be wrong. Who knows, right? We have no idea what the future holds. We don't even know what's going to happen in 10 years. So, Powell Zersky. Some people say that we should solve our problems here on Earth before we go to space. What are some of the most useful but less known discoveries or technologies that make our lives? NASA has a website called like NASA Spinoffs, and I think they've identified like 3,000 technologies that NASA have developed that have come to have made our lives better, and some of them are dramatic. They've done a lot of work on hydroponics and battery systems and solar panels and all kinds of things that are happening. But I think that when people say that we should solve our problems down here on Earth before we go to space, I think they're missing the point, which is that we are trapped in a place of finite resources here on the planet, and we are going to use them all eventually. We are going to, we have gone from the planet, the biosphere of the Earth being mostly in charge to humans being in charge. And as we continue on what we do, now maybe our population is due to go down by the end of the century, and maybe it'll just continue to decline and we'll reach some kind of stasis. But we're just going to keep using the resources of planet Earth, and we're going to keep putting the waste out into planet Earth. And so at a certain point, if we want to get off that cycle, we have to go to space. And so actually, I think the argument that I like to make with people is just Earth is the best place. And Earth is the only place that we know of in the entire universe that has life, that has all the forests and oceans and, animals and all kinds of things. And the rest of the solar system is rocks and water and volatiles. So let's try to help the Earth be the best that it can, and let's get off this planet, let's go to space, and let's start building things in space, let's start polluting in space, whatever we got to do, and let Earth recover and be the place for life. Glenton Campbell, what happens to us when the sun dies? Well, when the sun actually dies, the sun is consuming hydrogen, turning it into helium in its core, and it will eventually run out of fuel in its core. It'll blow it up as a red giant. It'll gobble up Mercury, Venus. It'll scorch the Earth, although probably the Earth itself will survive. And then it will slough off its outer layers, it will compact down to a white dwarf, and then it'll cool down to the background temperature of the universe. What'll happen to us? Well, the reality is that the sun itself is actually heating up. Sort of that process of hydrogen turning into helium in the core is building up this layer of helium. It's sort of causing the sun's core to expand a little bit, and it is causing more energy to come out in our region, and it's increasing the temperatures. And actually, by about 500 million years or so, to 1 billion years, the temperatures will get so high that it'll boil off the oceans. The sun, solar wind will throw that hydrogen off into space, and then the Earth will become hot, or will become dry like Mars. So. But I mean, 500 million years, again, we've only had smartphones for 10 years. Who knows what's going to happen to us? It's always funny that we want to have this long-term thinking, brush your teeth, exercise, eat well. Those are the things, those are the long-term things that we need to be concerned about. Let's see. Mania. Why have we never sent video from Mars, and when will we be able to do this? So what is video, right? Video is pictures, but just many frames of pictures taken, say, 30 times a second, 24 times a second if it's film. So really it's pictures, many pictures. And the reality, of course, is that the bandwidth to go to Mars and to be able to send high bandwidth data back to Earth is kind of a waste. And so instead, they send rovers, spacecraft that take photographs. They take as many photographs as they need, and then they're able to send those pictures back home. They were originally planning to put a video camera in the Curiosity rover, and I don't know if they've decided to put that into the Mars 2020 rover. But the reality is that that you can just take a whole bunch of individual frames and then you can stitch that into a video, and it's kind of the same thing. So, it's not super scientifically useful. And so they're so starved on the weight that they can send to Mars that they just focus on sending all of the scientific instruments that matter. And photographs work great for scientists. Gabe Smith, how do we learn about the makeup of objects in other star systems just with radio waves? Well, so radio waves are part of the electromagnetic spectrum. So you've got, when you think about the electromagnetic spectrum, you've got, on the one hand, you've got radio waves, and then you got microwaves, you got infrared, you've got visible light, you got ultraviolet, you've got X-rays, and then gamma rays. But they're all just the same thing. They're just different wavelengths of photons. But different photons are opaque, or the atmosphere of the Earth is opaque to different wavelengths of photons. So visible light comes through, obviously, while, say, X-rays and certain kinds of infrared can't make it through our atmosphere. So radio is just another tool that astronomers use. Certain kinds of particles, certain kinds of atoms will give off radio waves in a very specific wavelength, and it allows astronomers to know. The best example of this is this very specific wavelength that hydrogen gives off, and it tells astronomers that there is a large cloud of hydrogen because it gives off this, this very specific wavelength in radio waves. So 21 centimeter line. Man, I should have got some water. Might have to zip out for a second and get some water. Yeah, so radio is just another tool. And so often astronomers will look at an object in every wavelength that they can. You can look at a black hole in radio waves, you can look at it in visible light, you can look at it in infrared, and you see different things, and it tells you different pieces of the story. D-Stonks333, are there any metals in space that we can't get on Earth? Not that we know of. Now, there are metals that are more common, or actually they're really rare here on Earth that, hey Logan,
yeah,
could you give me a glass of water, please?
Sure.
I'm a little choky. Yeah, so things like iridium, palladium, these are pretty common in space, and they're not that common here on the surface. So they're very expensive to get to. But no, we don't think, like at this point, we have discovered every element that is possible here on Earth. Everything else that's higher up on the, on the atomic sort of line, we can simulate, we can make it, we can manufacture it, and then it degrades. So that's, there aren't any kind of like mysterious unobtainium that we could find out there in space. Thank you, sir. Oh man. Got to remember to do this next time. Drew Hurst. How did we measure light year distances to stars? Man, that is one of my favorite topics that nobody ever seems to want to watch the videos that I do them about. But astronomers use a technique called astrometry. Astrometry, but astrometry. And what you do is hold your hand out, right, like this. Like everybody do this now that you're watching. Hold your hand up and then blink your eyes back and forth, and you will see your thumb go back and forth, and compared to some background thing that's in your room. And so astronomers do this, but at a larger scale. So you've got the Earth, and the Earth is going all the way around the sun. And so you look at some star when it's on one side of the sun. And then 6 months later, you look at that same star and you watch how it changes back and forth compared to the background stars. And that tells you how far that star is. Use trigonometry and triangles and stuff to be able to figure it out. So it's incredible. And so Gaia, the mission that I'm like most excited about, it does that at just an immense scale. It's found like, it's tracking the positions of more than 1 billion stars using this technique. Yeah, I need halls or something. Always seems to happen. I got to remember talking, but we just cut this out. Yeah, I need that good Canadian whiskey. It's possible I have some. I had some last night. It was really good. All right. Question mania. I've heard news that NASA has built an engine that defies the conservation of momentum. Can you please explain more? Sure. So what you're talking about is this thing called the EMDrive, and it probably doesn't work. There were some people at NASA who said that it might be possible, but every really good test of this thing seems to be that it is interacting with the Earth's magnetic field somehow, and so it's not actually providing any thrust and not violating the laws of physics, which is nice. You have the same glass. It comes from Costco. All right. Whoa. Building with Todd. Fraser, do you think it's possible for a solar system to pass through a cloud of CO2 gas large enough to suffocate the Earth with? No. I mean, sure. Yeah, I guess so. I mean, if it was like a cloud of gas with the density of Venus's atmosphere, that would be bad. Sure. All right. Moonman 22, does that mean that precious metals are relative to the planet you're on? No, it means that precious metals are, they're common across the whole universe. I mean, we see gold in colliding neutron stars hundreds of millions of light years away. So it means that we are, everything that we find here on Earth is out there in the universe, just in different quantities. But we have seen asteroids. I mean, asteroids are easier to get at all of the, assuming you could actually get out there and dismantle an entire asteroid. There are asteroids that are made of metal. So, Easy Tiger. Do you think the Skylon space plane will ever fly? I don't know. Maybe. But its single stage to orbit doesn't really make a lot of sense, just in general, because of the rocket equation. So check out tomorrow's video all about a 2-stage reusable space plane. Now that is going to work because then you get all the advantages of space plane with an air-breathing engine and aerodynamic lift, and yet it's reusable. And so both halves can fly back down to Earth and land on a runway. So it's a really cool idea. I'm really excited about it. So definitely check it out. But the engine that the Skylon is they're developing is an idea that needs to be figured out, right? It's an engine that can pull oxygen from the atmosphere, compress it, and be able to provide it as an oxidizer is a thing that still needs to be figured out. But yeah, tomorrow you're like, I don't know, 12 hours away. No. 16 hours away. Scott Collins, remember that time the comet was coming? Everybody thought they were going to die because of the trace amounts of cyanogen gas in the coma. Yeah, 1910, Hubble. The comet, Halley's Comet. Everybody thought, so people bought like gas masks, and people had pills that would protect you from the comet. And of course, there was no problem. And in fact, they found cyanogen gas in this new interstellar object. And, same thing. Just it tells you that comets are similar, even if they come from other star systems. So amazing. Servers down. How do you talk to small-minded people who don't care about space? I think it's really important to not have conversations with people who don't want to have those conversations, right? Like, I don't bring up space to other people. If people ask me a question about space, then I'm happy to answer the question and talk about it, and we can have a great conversation about it. And if they're not into it, then I'm happy to talk about what's on TV or Canadian politics or hockey, although I don't even understand hockey. What's really weird to me is when people want to talk to me about space, but they want to be mean about it. And they want to, I don't know, say something really nasty or whatever. And again, then I get to choose to not have a conversation with them, right? I only like to have conversations that are fun. So if a person's mean to me or, is like really aggressive and obnoxious, I choose not to talk to them. And then I choose not to inflict my space knowledge on anyone who hasn't asked for it. And I think, it's great to have choice and freedom here. We should all be able to go and do whatever we want with our lives, right? So I think it's super weird to me when a person comes and rants on this channel and they're clearly not enjoying themselves. Like, are you sad? Is that what it is? You're just like sad and you want to just like, I don't understand. Anyway, go do something that you enjoy. Go have some fun. So that's what I think. Astronomy, when solar systems form, how does the dust that accumulates form into rocks? Asteroids. I always thought this would take the internal pressure of a planet to form solid rocks, then collide and scatter. So there's a couple of ideas, and this is actually still a bit of a mystery, but it looks like one of the ideas is electrostatic. So the first dust grains, you've sort of imagined this cloud of dust grains, and they're sort of rubbing against each other in this disk around the planet, and they're creating these charges, and they're sort of sticking together like dust bunnies. And then after a while, they get bigger and bigger, start to pile together, and then they just turn into larger and larger objects. But it looks like it's some kind of electrostatic force that kind of gets it all rolling. Alaskan ballistics. What do you think of Ryan Weed's antimatter rocket design using a radioactive isotope that gives off positron? It's on my list. I'm gonna do a video about antimatter rockets, but it's a dangerous. It's a topic that I have to be very careful about to make sure that I get it right. So there's a bunch of topics, and you should someday I'll show you what my list of topics looks like. But an idea comes into my head for a topic, and then I write it down, and then I just sort of wait and watch as more interesting stories come together. Like this one that we just did about these 3 telescope ideas. I had that on my list for probably 6 months, waiting for more and more of these interesting telescopes to come along, and then I pounced. And in fact, I'm going to probably do I'll probably just keep doing these, 3 more crazy telescopes you've never heard of, because there's so many great ideas that come along. And I really am enjoying sort of digging through science journals and things like that and finding stuff that my hope is you're not going to see anywhere else, right? So this thing that we're talking about tomorrow, I don't think anybody's talked about it. A lot of these telescope ideas. So you're going to have to get the goods from me. So I hope you're enjoying this. Curious board. Why doesn't Canada just build an arm big enough to lift us off all to space? Right? We can do that. That's the way. I love that idea. Let's see. The Delicious Plum says, I wonder if landing on planets is as important as building ginormous space stations. Building ginormous stations and sending them all over the solar system and cosmos may be the better investment. And in the comments, people noted the poster that I have right behind my head, which is that gravity wells are for suckers. Yes, I agree with you. I don't think it makes financial sense to land on the moon or Mars, and because then you just dropped into another gravity well. Just stay in space. It's the place. Raja Luthra. New research suggests that there may be a primordial black hole instead of a 9th planet. What are your thoughts on this? Oh, man. I saw the paper, and I was like, nope, not touching that with a 10-foot pole. I've been down this road before, right? I mean, it's the same thing as uh, Oumuamua is an interstellar spacecraft, and it's a megastructure around Tabby Star. Um, so yeah, you could take a black hole formed at the beginning of the universe. The only time that you could have these primordial black holes is at a time when there was like essentially folds in space that were high enough density that they just formed a black hole, and they could be any kind of mass, from the mass of a chair to the mass of a star. And now the only way that you can make a black hole is you have to have an imploding star. But right at the beginning of the universe, you could have had these primordial black holes. And so they could be everywhere. And in fact, this has been one idea proposed for what could be causing dark matter, although almost nobody believes that anymore, or if ever did. So yeah, you could take and so one reason why astronomers have had trouble finding the planet 9 is because it's actually a black hole. But there's no evidence that it is, right? And so this is the problem, is you could say that. And the astronomers proposed a technique that you could use to be able to find it. You'd essentially be watching for radiation that's coming from the event horizon of this primordial black hole. And it would be very small. It would be like the size of I don't know, like this big, right? But there's no evidence that it is. And so I think that when we as science journalists report on this thing, we have to be really careful about how we approach it, because it's super fun and it's going to get the clicks, and then people are going to come to our websites, and then we're going to make money from advertising, right? That's great. But it's also going to leave a little bit of, especially if it's not done well, it's going to cause misinformation, and it's not necessarily going to provide the kind of science literacy that we need. Although I am always on the fence. I love to report on this stuff, and at the same time, I feel like we have to be very careful about and responsible about how we do it. So this one seemed out there enough that it didn't feel like it was a thing that I wanted us to report on. But that's my decision as the editor of and publisher of Universe Today. But different publishers and editors will take a different stance. So that's it. I mean, it's almost certainly not. It's most likely a giant chunk of ice and rock, like all of the other chunks of ice and rock that are out there. It's just far and it's dim. And so people have had a hard time finding it. Scott Collins, but if it was a black hole, could we use it as the objective lens of a telescope? No. Well, I mean, maybe if you got really close to it. The problem is, we've talked about this a bit before, that, if you go out to say 1,000 astronomical units, you can use the sun as the objective lens as a telescope and have incredible power. And if you used and so people ask me, well, could you do this with Jupiter? Because Jupiter is closer and it's smaller. And the reality is that Jupiter is a worse telescope because it has less gravity. And so you'd actually have to go a lot farther. And so to use this planet I'm thinking you would have to go even farther because it would have less mass than Jupiter. So, Arjun asks, what technology would be created to test a black hole if it was nearby? Could we use it as a mega large hadron collider? Yeah, I mean, if we could find a black hole out there, that would be phenomenal, right? It would be an incredible opportunity for science, and who knows what we could use it for. We could use it for gravitational slingshots out into the rest of the Milky Way. There's all kinds of cool things we could do with it. So that'd be awesome, but let's go with the traditional approach first. Let's just try that. We'll try looking for a chunk of ice and rock and then go from there. But eventually, if we can't keep finding it, we've explored every chunk and yet the mass is right there, then it may very well be a black hole. And I understand as a, I, I'm responsible for some of this kind of hype and enthusiasm as well. So it's a difficult balance for us to walk. Dr. Ed Alcott, given parts of Canada are very remote, is there a push to build radio telescopes free from radio interference? We actually have a pretty great radio telescope here in Canada. It's in the Okanagan, and it's the one that was used to find fast radio bursts. Oh my God, I forget the name. Someone will say it in the. You think I would remember this? There's actually a whole radio telescope facility in the Okanagan. The Dominion Royal Radio Astrophysical Observatory, and that's in Caledon, British Columbia. So that's our sort of big one. And then the other one is Chime, of course, the one that looks like a sweet half pipe that was helped find fast radio bursts. I don't know why we don't have more radio telescopes in Canada. Australia's got a bunch of great ones. John Burr, how would a primordial black hole hold itself together in modern space? It seems to me that something with that little mass would push itself back out to regular matter eventually. Once you have a black hole, it's never going to get pushed back out into regular matter. It's not like, I don't know, it's like sucking itself in, and then when it gets not enough gravity, it sort of pops up into a chair or a planet or whatever it was before. A black hole, if a black hole evaporates particles, a black hole will be a black hole all the way down until the last couple of particles, and it will explode in a burst of gamma radiation in the end. So the idea for how you might be able to search for these primordial black holes is looking for these pops of gamma radiation as these black holes are evaporating away at the very end. Delicious Plum. I've been to the Okanagan. There are grizzly bears there. Beautiful bears, but it's best not to see them, even if they're at a distance. My wife and I did a drive back from Banff through the Okanagan, and we saw one grizzly bear and then probably 20 black bears. So, but we have black bears here on Vancouver Island. We see them all the time. We also have cougars. I've never seen one. We actually had a black bear. You don't leave the apples on your tree for very long if you're careful, if you're smart, because otherwise a bear will come and eat them off your tree. And so I went out one morning and it was like into September and I hadn't taken the apples off my tree. And a bear had gone in and torn a bunch of the branches off and pooped on the grass and half eaten a bunch of the apples. And then my neighbor, that bear, went into his backyard and it had been even later. And so he had a pear tree and the pears were getting a little fermented. And so the bear got drunk and was passed out under his pear tree. And so they just kind of waited for the bear to leave. But yeah, so we have bears and cougars here. We have the highest density of cougars in the world. But I've never seen one. And as you may know, I hike all the time in the forest, in the mountains, and I've never seen them. So, although apparently you got to see them more north. Let's see. Scott Collins, could the breakthrough starshot laser system or something similar be used for asteroid redirection? If the market is ever established for asteroid resources, it could help pay for the system. Yeah, absolutely. If you one of the ideas for how to redirect an asteroid is to shoot it with a powerful laser. And the laser will ablate a little bit of the asteroid surface off. It'll act like a little thrust, like a little rocket. And you continually zap your asteroid and you can change its orbit with its own mass. And it may very well be that that's the way to do it. It's a great idea. It's one of my favorite ideas for how to move asteroids. And that would also could be used for sending spacecraft off to Alpha Centauri. So you can imagine some future where there's a whole bunch of these lasers and they're out there in the solar system and they're constantly just zapping asteroids one after the other and just organizing them all into the perfect system that we can then harvest most economically. It's a great idea. Krishna Lackman, do you think we are going to discover if there's life or possibility of life in Alpha Centauri in our lifetime? Yes, we will have the capability to determine if there is life on Alpha Centauri within our lifetime. So you're going to need a telescope that can directly image planets going around another star. And there's a bunch of these in the works right now. You've got the extremely large telescope that's going to be built on the ground. 2026, 2027. That's the 39-meter telescope. And then you've got some space telescopes. The James Webb probably won't be able to do it very well, but there's going to be a plan. There's a spacecraft called Habex. And then after that, it's going to be one called Luvoir. And so I think within the next, say, 20 years, there will be a telescope either on the ground or in space that will be capable of directly observing another planets around Alpha Centauri for sure. And because it's the closest, right? Or Proxima Centauri is the closest, but Alpha Centauri is pretty close. And they will look for biosignatures and they'll try to know if there is life there. Now, of course, you can't prove a negative, right? You can't prove there's no life there. But if there is a really clear indication that there's life there, we would be able to detect it. And it'll definitely happen within your lifetime. I think we will know if there is life in the universe 30 years from now, 20 years from now. Like, we will know to about a 95% accuracy whether or not we're alone in the universe. And it's just that we will have powerful telescopes built within the next 20, 30 years, next few decades, that will see enough of a sphere around the Earth and not see any life, to say, okay, we've examined enough of the Milky Way and we haven't seen any sign of any life at all, that probably the rest of the Milky Way doesn't have any life in it as well. And that's in your lifetime. That's in our lifetime. You know, depending on how old we are. I'll probably be retired when that actually happens. I'm never going to retire. So I'll probably be, in my 70s when it happens. But I feel like that is a thing that we will know. And it's pretty exciting. And there's and that's why I love to talk about these great telescopes that are coming. Trey Harmon, is Alpha Centauri visible from the northern hemisphere? I think it is. You just have to be close to the equator. So I can't see it from here, but I think if you go down to, I don't know, Central America, you can see it. So, and if you're on the equator, for sure. So you can see it in the northern hemisphere, but not up here. It's definitely an object seen in the southern hemisphere. And if you go to Australia or South America or South Africa, you can see it. And I have seen it. It exists. Jiro the Hero, since our current propulsion would take us many tens of thousands of years to get to the nearest stars, have there been any studies on making generation ships? Yeah, there's been a few interesting studies that have been done. Mostly it's sort of people saying, like, how many people would it take to have genetic diversity to be able to make a generation ship work? And the number's pretty small. It's like a couple of hundred people. And then the next question is, like, how much mass would you need? And the reality is, you could take an asteroid, a medium size, a few 100-meter asteroid, and you could send that on a journey to another star system, and you could have robots and people dismantling that asteroid and using it for fuel and for building materials and for whatever you require, and that would work. So the actual physics or the actual engineering involved, we don't know how to do that, right? We can't make a machine last for very long before it breaks down. We don't understand how to run a closed environment where every single everything is recycled perfectly. Like, we are so far away from this kind of technology. Hey, Cody. Cody says, hey, what do you think about the idea to do SE starshot? What? You're going to have to, I will stick around. I'll get your question, man. All right. So the Delicious Plum asks, did I read something recently that there were detections of the atmosphere of an exoplanet? And if so, what might this tell us? Yeah, I did a video on this. They detected water vapor in the atmosphere of another planet. And it doesn't tell us anything. It tells us that there was water vapor in a planet, which is great. But we don't know of any, it doesn't tell us if it's like water on the surface. It doesn't tell us how much water is, just that there's the presence of water vapor, which is great. It's a start, but it doesn't tell us. All right, so Cody is asking, use starshot to start a fusion reaction. I have not heard of this. I want to do an update on Breakthrough Starshot, so I'm going to look into that. I'm sorry, man. I thought I knew what you were going to ask, but I don't. So I'm going to have to dig into that. I'm sort of imagining that you would use the laser that is going to be sending the spacecraft to another star system and use that. Like they use lasers to run fusion reactions. So maybe that's what they're talking about. Interesting. I'll look into this. I guess on that note, we're up to the end of our hour, so I need to wrap this up. Thanks everyone for watching. Thanks, of course, to our moderators. You were busy today. Again, tomorrow is a 2-stage spaceplane. I'm really excited about it, and it's a great video. Chad did a great job on editing this one together, and then lots more good stuff coming. So stay tuned. All right. Thanks, everybody. I'm now going to do the uncomfortable stop the broadcast, but we'll see you all next week.